ASDIP analysis includes the calculation of wind pressures on a structure per the ASCE 7 code. But how do you actually enter the wind parameters and the building geometry into the program? How do you analyze the results? This is Javier Encinas, and today I'm going to present an example from scratch of a building subject to wind pressures. Let's get started. As an example, consider a gable roof structure. The building dimensions: bridge height 25 feet, eave height 15 feet, building width 40 feet, and building length 80 feet. In addition, we know that the building is located in exposure category V. The basic wind speed is 100 miles per hour. The building is a risk category 2, and the building has been classified as a partially enclosed building. With this information, we are required to find the wind pressures on the structure for both the main wind force resistance system and for the components and cladding. This is a gable roof building as shown here, and we will use ASDIP analysis in this calculation. Let's go there. When you open ASDIP analysis, you see the modules included in the package: seismic loads, snow loads, wind loads, and beam analysis. In this case, we're going to run a calculation of a wind loads. I have prepared an example for this purpose. Let's double click on this node. And this is the template of the wind loads module in ASDIP analysis. In the wind parameters tab, we enter the exposure category C, and the basic wind speed V is 100 miles per hour. All this information was given in the statement of the problem. If this information is not available, you can click on this link. This site provides a very good information about it. Let's click on the building tab. Here we enter the risk category, is risk category 2. And here the building geometry. All this information is given in the statement of the problem. Ridge height 25, eave height 15, building width 40, building length 80 feet. In addition, we know that this is a gable roof, and the enclosure classification of the building is partially enclosed. In addition, for the components and cladding pressure calculations, the effective area for the roof is 100 square feet, and for the wall component, the effective area is 100 square feet as well. At the right-hand side, we see the calculations. In the building geometry section, the program calculates the roof slope and then the mean roof height. In this case, is 20 feet. The program checks the low-rise building criteria. The mean roof height age must be less or equal to 60 feet. That complies. And also the mean roof height age must be less or equal to the minimum of the width and length of the building. In this case also complies. So we can use this analysis. The program checks the velocity pressure. In this case is 23.1 psf, and calculates the end zone A. In this case is 4 feet. The program calculates the main wind force resistance system pressure coefficients. The positive internal pressure coefficient is 0.55, and the negative internal pressure coefficient is -55 as well. Then the program calculates the design wind pressures according to this formula in the tables below. Please note that the program shows the references to the ASCE 7 for granular check of these calculations. The ASCE 7 prescribes 4 load cases. The program shows the wind pressures in a tabular format. At the left, the surface zones. Then the program calculates the external pressure coefficient and calculates the wind pressures according to the internal pressure coefficient. So the program shows the wind pressures in these tables immediately. We scroll down. The program also calculates the components and cladding, roof pressure coefficients, and wall pressure coefficients. The program follows this formula from this reference, and these are the wind pressures for roof, components, and cladding. Here at the bottom is the calculation of the components and cladding wall pressure coefficients, and according to this formula from this reference, the program calculates the wind pressures for wall, components, and cladding. Graphically, if you go to the Graph tab, the program shows the main wind force resistance system load cases, 1, 2, 3, and 4, showing the zones that are referenced in these calculations. In addition, the program shows the component and cladding roof, showing the zones referenced in the calculations, and the components and cladding for walls. As you can see, it's very easy to calculate the wind pressures on a structure using ASDIP analysis. We were able to find all the pressures for main wind force resistant systems and also for the components and cladding just in a few minutes, which otherwise would be much longer if you try to do it by hand. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.